What I want to show in this session is historical approach of how the wide area network technologies evolved in such a way that enterprises had to adopt SD-WAN solutions. So uh, historically, in order to have wide area networks, enterprises will use carrier-based private networks. They were good because a carrier usually span large geographical areas. And for instance, if your enterprise has several remote offices scattered across one country, using a carrier-based private network makes sense because the carrier span large geographical areas. So the carrier will place what is known as POPs, which are sites that are close to each remote location, and you will establish a link between your remote office and that POP, usually using fiber or copper for old carriers. Your data is private because the only one that can take a look at your traffic is the carrier if he wanted to, nobody else. So in the 90s, frame relay was heavily used. Frame relay was a hub and a spoke solution in nature. So you have one side that becomes the hub, that is usually your headquarters or data center, and the other remote sites will be the spokes. So given you will have your servers and applications installed in your hub, what your remote sites or spokes will do will be trying to access those applications through the hub. The nature of the hub and spoke topology provides some drawbacks. The first drawback is oversubscription. Notice that all the traffic coming and going to the spokes will have to travel to this link. So if these links become saturated, you will need to acquire more bandwidth. That means spending more money. So the other drawback that hub and spoke topology exposes is the increased delay. So for instance, if this office wanted to establish a voice over IP call to this other office, this traffic will have to travel to the hub and come back through the hub to the other spoke for every single voice over IP packet. So what you want with your wide area network is to have a full mesh where one office has direct communication with all the remote offices and so on. It was possible to have this with frame relay, but it meant spending more money because you will have to set up a lot of PVCs. The carrier will have to set up PVCs between your POPs where you're getting connected, and each PVC had a cost. So in summary, frame relay was good to connect your wide area network, but it was not full mesh and it was expensive. The technology that replaced frame relay is known as MPLS. MPLS provides you with a full mesh connectivity natively, and it is still costly. You can acquire a high bandwidth with a cost, and remember that each router requires a special licensing in order to work with MPLS. So MPLS is good to connect your wide area network. It provides you with a full mesh, but it is still costly. So as the internet evolved and it provided more bandwidth at higher speeds, enterprises noticed this and started using the internet as a backup solution for the MPLS. In this case, this was the usual setup where you will acquire a public static IP address at your hub and dynamic IP addresses at your remote sites, because IP addresses come with a cost, and having a static IP address is more expensive than a dynamic one. So with this setup, you could reach a hub and a spoke solution with using internet with IPsec tunnels. So you will create manually an IPsec tunnels from each remote site to your headquarters or data center, and with all the disadvantages of a hub and spoke topology. You could enable full mesh, but it was somewhat difficult because these IP addresses were dynamic, and you need to enable other features and services in order to make this possible, and still you will need to create manually your IPsec tunnels, so you will be creating dozens and dozens of tunnels, which is not feasible or recommended. So at some point in time, Cisco came up with DMVPN, which is a cool solution that lets you create tunnels on the fly. With DMVPN, you still need to create these IPsec tunnels. You will use IPsec with GRE, and when this office, for instance, tries to communicate with this other office, it will create a tunnel on the fly, which is really cool. So I am talking about Cisco because I am more familiar with Cisco, but that doesn't mean that other carriers were not creating similar technologies. So DMVPN will provide you with a full mesh of tunnels using the internet, and it will require you to use routing tuning. For instance, if you still wanted to use MPLS as your main connection, if you were using OSPF, for instance, you will apply here a metric of or a cost of 1, and for your DMVPN connection a cost of 10, for instance, to provide a better metric for MPLS. And the same happened when the mobile networks evolved. So we started having better bandwidth wirelessly to connect to the internet, and the enterprises noticed this, and they started using these solutions as a second backup for connecting their remote offices. So you had MPLS as the primary link, fiber-based internet as your secondary link, and wireless internet through mobile network carriers as a third link. You must make sure to use this link with care because it can become costly. Remember that carriers will charge you per megabyte that you transmit. So make sure that use these links only for survivability applications. So you could enable DMVPN for your fiber-based internet and DMVPN for your wireless-based internet. So you have 2 DMVPNs plus MPLS. So in order to have this, for instance, if you were using OSPF, you should apply a cost of 1 to this MPLS connection, 10 to your fiber-based internet, and 100 for your 3G or 4G based internet. Later on, Cisco came up with IWAN. With IWAN, you will have intelligence applied to your wide area network because you can only go so far with routing protocols. Routing protocols take action when adjacencies between your routers go down, mainly due because a link went down. But what if you want to take action if a link is still up, but it is showing up packet losses or high latency, or it is started to become saturated? So IWAN provides you with intelligence to, for instance, see if this link is starting to lose packets. You can divert traffic to another link without waiting for this link to go down. Or if this link is start to become saturated, maybe divert some traffic to other available link. So you will need other servers in order to accomplish that, and these servers could be placed on the cloud as well. So what were other issues that enterprises faced when trying to deploy wide area networks? The main issue is provisioning. That means that you will need to send a router to the remote office and have an engineer connect to that router and start typing some commands in order to set it up, and have another group of engineers provision that IP address, that new IP address of these new servers into for instance, a network management server that works with SNMP, or a server that creates statistics, or a server that creates or manages your orchestration. So you have to provision these services as they are installed. But what happens as more sites get added? So think, for instance, a retail company that has to set up 500 remote stores. So you will need to send 500 routers and mobilize a team of engineers to configure those routers. And what happens if this engineer configure this in a way, and this other engineer configures this other router in another way? So you will start having different configurations in your wide area network. And what happens if these engineers that are provisioning these new IP addresses in all your servers forget to add one address, or forget to check if one address is generating statistics correctly? You will start running into operational problems. So this is why SD-WAN was created, to address all these issues that we have talked about. For starters, it will provide you with a centralized way to install your intelligence of devices. Would have enough intelligence to have an holistic view of their network. Will have to be installed centrally, probably in the cloud or in your premises. So these centralized devices will have a complete view of your network. Will notice when one link starts to get more latency, when a link starts to get saturated, and so on. So you will be bringing intelligence with SD-WAN to switch over traffic or divert traffic when some of these issues happen. It will also be technology oblivious. So this device can get connected to an MPLS, to a fiber-based internet, or to a wireless-based internet. No matter what, your SD-WAN solution should be able to accommodate any link that you want to use. And also, SD-WAN should be plug and play and provide you with automatic provisioning. So in these cases, your SD-WAN solution will require someone with a low level of skills in order to get you connected. You don't need to send a qualified engineer to every single site in order to get your site connected. Anyone with a minimum amount of knowledge should be able to get your devices getting ready. And when your devices get connected, they will communicate with your centralized solution in order to tell them to get this device provisioned automatically for you. So you don't need an engineer here typing in or provisioning manually every site that it gets connected to your wide area network. It all happens automatically. And mostly and most importantly, these SD-WAN solutions will provide you with an API. It will provide you with an API so you can, as a user, communicate using software, using this API to take control over your wide area network. And it will also publish several APIs. For instance, it will provide an API so your remote devices can use software to communicate to your centralized solution. It will also publish an API so you can have servers, for instance, ticketing servers, communicate with this solution so they can tell or generate a ticket for incident management if a link goes down, for instance. That's it.